Okay, so good afternoon, everybody. Thank you for joining the session. The session today is optimizing the future, the 5G and IoT revolution. Here's what to expect. And all of you know this is a big data and AI cloud and cybersecurity conference, September 2020. So just before I start with the presentation, let me make a disclaimer about this presentation. The views and opinion expressed in the following presentation are those of the individual presenter, which is me, and should not be attributed to my employer, my current employer, Rogers Communication, its directors, officers, employees, or affiliates, or any organization with which I am as a presenter has been employed or affiliated. Today, the session agenda, we have introduction. I'm gonna introduce myself very quickly, and then we're gonna talk about 5G overview and technical aspect, use cases, and then we're gonna talk about the business implications. We're gonna, tackle privacy and security. So this is me. My name is Ferris Adi. I work for Rogers Communication as Security and Compliance Manager. And I have more than 15 years of experience. I'm specializing in information security, governance, IT risk management, privacy. I work for clients in telecom, financial services, construction, engineering, and retail industries. Currently, I am an instructor at University of Toronto, cybersecurity management program there. I hold a Master of Business Administration from Norwich University in Vermont. I'm also a frequent speaker at cybersecurity conferences like ISACA, IC Square, the CISO Forum, Data Connectors, and Information Security Forum in Dublin, Ireland in October 2019. Let's start now with the presentation. We're going to talk about 5G overview and technical aspects. Some of the information, maybe the first time maybe you hear about 5G. So with this slide, this is the key 5G capabilities. So let me take you back to the first generation of the wireless network, the 1G, that brought us as a consumers the analog voice calls and then SMS. With 2G, when we had 3G, I think everybody recall that we were using web browsing and high-speed data and video streaming with 4G. Now with 5G, we're gonna handle high throughput up to 10 gigabytes. We're gonna cater for more devices per kilometer up to 1 million to support the massive IoT requirement. Also, 5G comes with ultra low latency, which is 1 millisecond to support the business critical use cases. So the lag between sending a request and the network responding will theoretically drop to 1 millisecond, which is 400 times faster than the blink of an eye. Also with 5G, we're gonna have a large bandwidth because the LTE usually has 20 megahertz. In 5G, it will become 100 megahertz on the 3.5 gigahertz range. With 5G also, we're gonna have a low energy consumption, up to 10-year battery life for machine to machine, which is gonna be part of the IoT communications. Also, we're gonna experience a stronger signal in the crowded areas. Now, let me remind you the differences between 4G and 5G. The big differences is faster speed. I mean, between 4G and 5G, we're gonna have a faster speed, we're gonna have a higher bandwidth, and a lower lag time in communications between devices and servers. Now, in this slide, the 5G wave in 2020 and beyond. So I'm trying here to explain what's the basic idea about 5G. So 5G is a complete ecosystem, and this ecosystem involves three key components. We have the chipsets that you can see on the slide, and example of those chipsets can be as Qualcomm, the providers, the Intel and Samsung. And this chipset represent the processor and the modem. Now, devices also, we can have such devices such Samsung or iPhones, and devices, as we said, can be mobile phones, could be routers or IoT sensors. And the device support depends on the type of the chipset. What we are using, the type of the chipset. The mobile network should have new radio site that support the 5G along with the 5G core. So I'm trying here to explain, to have 5G service, we need to have both compatible, the devices and the network. And so your current phone, if you have a 4G phones, they don't support the 5G network. Now, the 5G signals, they run over new radio frequencies, and they require updating the radios and the other equipment on the cell towers. Some of you might ask me, okay, what exactly the timeline here, or what represent? So the timeline in this slide represent the readiness in each domain or part of the 5G ecosystem. Also in the past, some people, they were asking me, okay, what's the third generation partnership project, which is the 3GPP. So in a nutshell, or on a high level, it's a project bringing together the national standard development organizations from around the globe, initially to develop technical specifications and protocol for the mobile telephony and cellular telecommunications. And the 5G is designed by the 3GPP standard to be more secure compared to the previous technologies due to the advancements happening and different layers and the business requirements. Let's now have a quick view on the global 5G forecasted insights. So I'm not gonna go through the slide. I'm not gonna read everything here in the slide. This is just, for you to have like a snapshot about, the major global 5G forecasted insights. So 5 billion people forecasted to be accessing the internet via mobile by 2025. 5G coverage will roll out rapidly to cover 40% of the global population by 2025. And the most interesting thing, according to Ericsson, by 2025, volumes of mobile data traffic are expected to increase by a factor of 4, and 45% of the traffic will be carried by the 5G networks. Also something interesting, 25 billion Internet of Things, which is the IoT devices globally in 2025, we're gonna have with 11.4 billion consumer Internet of Things. Also, we're gonna expect 13.7 billion industrial IoT in 2025. So this is the forecasted number. So this is why we're gonna speak in the coming slide way about the IoT devices and how we expect to have not million but billions of devices. And thankfully, this is because of the 5G. Here, just to see the 5G roadmap between 2018 to 2023, this is the roadmap and the ecosystem expansion. So as you know, there is a continuous research. We have an early vision, a prototyping drive, and reflecting standard between 2018 and 2023. And the continuing expansion is gonna get to new verticals, deployment, more use cases, and spectrum. And we're gonna see this, hopefully starting with 2020, more 2021, more use cases until 2023 when we have the expansions. Now we're gonna talk about something so important and interesting about 5G. I'm not sure if you heard about this terminology somebody mentioned to you, or did you hear about network slicing? So as we mentioned clearly, and we have to keep clearly mentioning that 5G will be based heavily on the network function virtualizations, the mobile edge computing, and the software-defined networking. So the virtualization of the mobile network is a key part of 5G. And one of the areas to achieve a quick slicing is virtualization. So the whole idea about 5G is the transformation of slicing. And we said slicing as a service. And when I say slicing here, I'm referring to, or the meaning is efficiency. So the network slicing is a type of a virtual networking architecture at the same family as when we talk about the software-defined networking, network functions, virtualization, and the orchestration. And we need this, why? To maximize the efficiencies of shared infrastructure while ensuring the isolation, the performance, the features, the attributes for each network slice. So the network slicing, what it will enable the carriers to divide the 5G radio access network into virtual segments. Each of can be customized to support the different types of applications. Also, the slicing will allow the wireless carriers to essentially create multiple independent virtual networks to separate users' devices and applications from one another. Something important about the network slicing, it will permit a logical separation of network, meaning that each slice, it will provide unique connectivity, but all the slices, they will run on the same shared infrastructure. And this separation is going to be used to provide guaranteed resources for a mission critical applications and with the critical traffic dedicated to a network slice or special properties such as low latency, lower cost, and the massive scale. Give you an example, a network slice that is going to be used by the healthcare segment to communicate information about patient information requires a lot more security than a network slice that is being used by a gaming company to provide access. However, now I need to keep talking about, maybe because of my background in security, it always kicks in. Network slicing also will create a new security challenges as each virtual network slice could demand unique security capabilities that need to be managed in a coordinated manner. At the minimum, the expectation will be that network slices will be highly isolated to prevent malicious attacks and the spread of vulnerabilities or faults to the other inter-slice or inter-slice component. Now, since this conference talks about AI, I'd like to mention that AI has a potential for 5G telecom carriers as it will allow them to optimize their investment, reduce cost by driving accurate 5G network planning, produce capacity, expansion forecast. Also, it will enable dynamic cloud network resource scheduling and delivering 5G smart networking slicing. As I said, again, I'd like to share this slide about IoT and network slicing because they are very important topic, both of them. And currently, the IoT devices contribute for 16% of the traffic, but account for 78% of the malware on the mobile network. And many of the IoT devices, they can suffer real problems, especially when they don't receive frequent update. We're going to talk about this later in later slides that address security issues to protect them from vulnerabilities. And the network slicing is one of these technologies that will enable greater degrees of security for the 5G network. Now, beside network slicing, there's an important also terminology here. I'm not sure if you hear about it. It's edge computing. But I think going forward, you're gonna start hearing about it a lot when people talk about edge computing. So let me explain to you edge computing. What it's edge computing is distributed computing, which brings computer data storage closer to the location where it's needed. So computation is largely or completely performed in a distributed device nodes. And the edge here refers to having the computing infrastructure closer to the source of data. So now we're gonna make more the infrastructure, we're gonna bring the infrastructure closer to the source of data. So the edge computing coming with an ideology of bringing compute, storage, networking closer to the consumer. Now, I will give you like examples of edge computing. It could be mobile devices, could be smart homes, smart cities, also smart street lights. So now 5G and edge computing, 5G will facilitate the edge computing, which takes computing away from the core of the network and places it at near the source of the data. Now, the compute would likely to be orchestrated across devices themselves, enterprises, data centers, or close to the edge computing, or the device vendors, data centers, public cloud, etc. And it's going to be all managed, they owned and managed by different providers. Now, the nature of the services and capabilities enabled by 5G networks is also going to stretch the storage demands for a much wider range of smart connected devices. Give you example, on autonomous cars, for example, we're receiving data from other nearby cars, infrastructure elements, and the environment around it via 5G, and all that data will be need to process locally. Now, why we need the edge computing here? Edge computing, we need them because we need a real-time responsiveness. Sometimes the reaction time can be a critical factor. Reliability, the system is capable to work even when it's disconnected to the cloud servers. Edge computing analyze and process only the subset of data, and they discard, any like raw information and incomplete sites. It does not really verify whether the user was authorized or not. So as you can see here, we have sensors, controllers, then we have the edge, and then we have the cloud, and we are going to expect here in the cloud with a big data processing. We need a business logic and data warehousing. At the edge, we're going to have a real-time data processing at the source on premises. We're going to have more data visualization, basic analytics, data caching, buffering, data filtering, optimizations, and M2M communications. And here we're going to talk again about the big data. And really, we cannot really send everything to the cloud. So we need to do more like filtering because we're going to have tons of data here, as I mentioned earlier. Now, security at the edge, again, remains a challenge, primarily because there are highly diverse use cases for IoT, and most IoT devices do not have the traditional IT hardware protocols. Therefore, the security configurations, the software updates, which are often needed through the life cycle of the device, may not be present. And as several new intelligent devices are connected to the network, configuring all those devices in the right way may result in the risk of a human error. So this is just we trying to, what are, we have advantages, also we have security challenges. And I'd like to mention here about the edge something important, and I keep referring, maybe I'm going to refer more and more in the presentation for the healthcare. For healthcare practitioners, edge computing can place the computing, close to the device, such as the heart rate monitor, and this will ensure reliable access to possibly life-saving and health-related data. Now let's talk about use cases here, a quick about the use cases, because everybody wants to know, okay, what are the use cases here? What exactly we are talking about? So from use cases perspective, we have the first one is enhancing mobile broadband, because it's very important to note that the initial 5G, the new radio, which we call it the NR deployment, will focus on the enhanced mobile broadband. And the use cases here to boost capacity and provide an elevated mobile broadband experience, like the extreme throughput, the faster speed, and lower latencies. So we're going to have more real virtual reality, more uniform experience, UHD video streaming, and this is something it's it's going to be very interesting. Now, the interesting piece here that I'm not sure if some of you heard about it, which is the tactile internet. So tactile internet is going to be the next evolution that will enable the control of the IoT in a real time. So this will add a new dimension to human to machine interaction by enabling this tactile and haptic sensation at the same time, also will to the interaction of machine and human beings. So this will enable, or the tactile internet will enable haptic interaction with visual feedback. So this is why this is like different, or this is going to be something new, and because of this enhancing mobile broadband, so will enable this tactile internet, the haptic interaction with visual feedback. And here the term haptic, it relates to the sense of touch, the perception and manipulation of object using the touch. Also, seamless networks connecting in an ever-expanding array of things to a richer set of applications and services, from devices powering the smart cities, autonomous vehicles on the road, to smart home hardware, and of course mobile handset. So what we are trying to say here, tons of millions of devices can and will be connected to the 5G. Now let's talk about connecting the mass to the mass IoT. And this is what makes the 5G potentially a revolution, because it's an enabler, energizer for a wide range of coming changes that can rock the people they live and they do the business. It's aligned with autonomy, embraced by the artificial intelligence and supported by big data, and enabling the greater mobility. And it will promote such technologies as autonomous vehicles, robotics, smart home, cities, and hospitals. And will have more power efficient, more low complexity, and will have more long range. And as you can see, for utility, I'm not sure if you heard about the smart metering. So all of this we have to say because of 5G. So this is why 5G will make all of those changes, and those use cases, they are today, and we're going to see more use cases because of 5G. The other use cases is enabling the new mission critical control devices. So here, as you can see, we have autonomous vehicles, industrial automation, which is high reliability, aviation robotics, ultra low latency. We have energy, the smart grid, and medical, and it refers to the high availability. So with real time now, we can have a communication vehicles to vehicles. Every vehicle can know where the other vehicle is all the time, with adjustment possible within 10th of a second, leading to improved safety and reliability. So this is one of the benefits we have with this autonomous vehicles. But I would like to mention something I came across in different articles. I'm not sure about it, which if you heard about it, the security vulnerabilities and the complex supply chain. And here I'm going to talk about the automotive manufacturers. So as you know, with these autonomous vehicles, the automotive manufacturers, they rely heavily upon third-party vendors to supply the system's hardware and software component for those vehicles. However, unless the auto manufacturers impose a rigorous cybersecurity requirement on the tier 1 and 2 suppliers, they're going to run to the risk of introducing security vulnerabilities via those components, those component security. And some of it, it's, I think the root cause is the lack of design-in security. So the automotive industry has little historical experience of dealing with cybersecurity risk. And this has become evident from the lack of security built in for many of the software and hardware components on the first generation of connected cars. Also, there is a lack of rigorous security testing, and this is much take place too late in the product development life cycle. So from experience of what we have seen in the industry, there is no design, there is a lack of design in security. And when testing for security, it happened too late, in the life cycle, in the product life cycle. So, which means, we don't have a strong or a robust security process for those, applications, hardware pieces that, that they are used on those autonomous vehicles. Also, let me talk here very quickly about 5G and enabling the health opportunities. As you can see here, we're going to have digital health players network. We're going to have telecom companies playing a role here. Of course, the healthcare providers, hospitals, doctors, the telco suppliers, chips, network equipment, and software. So we're going to have like the data transfer between players, and this will increase the exchange between healthcare providers, the payers, the patient, and regulators, and also the patient. This will create opportunities, and those opportunities, we're going to have electronic health records, we're going to have IoT fitness apps, and this will increase the data volumes and exchange, leading to additional revenue for the telco providers. Also, the healthcare, it will increase mobility, will reduce the cost. So when we have those devices, it will increase mobility, will reduce the cost, such as the appointment, the scheduling, the telecare to reduce doctor and nurse visits, the treatment of chronic diseases. However, we're going to have challenges, and those challenges, which is increased reliance on the network, would require investment and technical improvement of the infrastructure, which is the speed, reliability, and coverage. And this is very important. Also, the other piece, the privacy and confidentiality, cybersecurity regulations, and compliance. So the integration of the IoT of things and the cloud computing is becoming a driver for the digital transformation in the healthcare industry. And the emergence of the cloud-assisted e-healthcare systems, they will enable the patients to provide their personal healthcare information to a high quality and efficient medical services. While this paradigm shift has brought new opportunities and benefits to the healthcare organizations, also it raised many security and privacy challenges. And here I have to mention that hackers, going forward, they will focus on the healthcare, as you know, because your health data now is more on the black market or the dark web than the financial data and the credit card information. So sensitive information about the patient, like the location of information, physical condition obtained from these sensors, must be protected against any threats while transmitting over to unsecure wireless channels. Something important to mention that I have seen some videos on YouTube about remote surgery because of 5G. Now, for remote surgery, they become possible, and a human surgeon can control a surgical robot across a greater distance, which I think in China I have seen it with one. The doctor was like far away, 1,000 kilometers from the patient, with immediate real-time interaction, including not just the sight and sound but the haptic feedback, which is very important. Also, I have here a video. I'm not sure if I can play it, but this is an experience of an ultrasound with a haptic glove between an ambulance on the road and the hospital through a VoLTE-based mobile phone call over 5G using the IMS data channel concept. I'm not sure if I can play this to you. This is maybe 2 minutes. So let me try if it's gonna work.
Here we're showing real-time interaction in 5G. So with 4G we had a real-time communication, we had voice and video. With 5G we want to add the capability to touch and move over the network. So one use case we're working on with King's College in London and British Telecom is around a connected ambulance. Here we're going to show a connected ambulance en route to the hospital, and we'll step into the use case. So Teresa, you've gotten into the ambulance.
Okay.
We're on our way, we're on the countryside. We have a very good paramedic, but he's not a doctor. We think you've injured your hand.
Okay.
We think we might need to do a scan for a blood clot. So Eugene is going to set up a call back to the hospital that we're en route to, the emergency room. And now we have Dr. Mario popped up on the screen. So now Mario can start diagnosis communication with the patient. He agrees we need to run an ultrasound. So we've added a 5G data channel to this VoLTE session. And over this low latency and QoS channel, we run the ultrasound application we have running on the PC in the ambulance. That application's carried back to the doctor. He has control of the application, as well as he has a haptic joystick giving instructions to this glove.
So the doctor is actually steering the ultrasound around my hand.
Correct. So the paramedic is trained with the glove. It has an array of sensors and vibrating motors. They give instructions from the doctor in real time. So the doctor is able to communicate with you and diagnose you. The paramedic is like a surrogate or a robot arm for the doctor.
Wow.
So in this scenario, he can confirm the diagnosis. We can either reroute you to a different hospital, or potentially bypass an emergency room, head straight into a theater where we can start the diagnosis, start the treatment process. So this is one example of how we can use 5G to evolve communication and support the healthcare vertical.
And really make healthcare better for people, and we could save lives with this.
Absolutely, save lives. I think we save costs on the hospitals, the system, try to save really the society a lot of the wasted time and effort. So,
fantastic.
Very good.
So hopefully, you enjoyed the video. It was a short video, but I think this is just enforce, what I was talking about, the 5G and how it's gonna help, a lot to save life and save cost as well. By the way, since I'm talking here about the health, because I was in different conferences, I was asked about the COVID-19, and there was a theory about 5G and 5G cell towers they were used, or was the reason why the virus was spread. And I can tell you, COVID-19 is a virus spread by person-to-person contact, not radio waves. So to date, there is no evidence to support the theory that 5G network cause COVID-19 or contribute to its spread. Okay, let's talk about now the last, I think, and here we're going to talk about the business implications, privacy and security. So let's focus here on the IoT, and here what's the potential, challenges in the IoT systems. So as you can see here, the potential challenges in IoT, 5G will become the backbone of IoT, and 5G means unlocking the potential for us to interact and connect with machine in unbelievable ways. So I'm gonna mention some statistics, some numbers, because I like numbers, and based on those numbers, it's expected the global IoT market will exceed the value of US dollars 1250 billion by 2025 from US dollars 690 billion in 2019. So huge increase. Based on Gartner's forecast database, we can expect there is going to be approximately 14 billion devices connected to the internet by 2022. The Cybersecurity and Infrastructure Security Agency, the CISA, listed more than 12 OT system related vulnerabilities, and these issues came from more than 300 original equipment manufacturers. And the root cause of this proliferation of these cyber threat, is that in the areas like OT and IT are often not synced with the security strategies. So those cyber threats in OT and IT, they are not, often synced with security strategies. IoT devices, they are not only collecting valuable user data, they could become an entry point for an attacker or tool to launch a distributed denial of service attack. Individuals around the globe will generate thousands of terabytes of data, and securing all of this data from criminal exploitation will be increasingly difficult. 5G technology also, it can enable the weaponization of IoT devices and the botnet attacks, and by allowing more devices to connect, 5G can potentially enable them to become part of the malicious botnet through which hackers can launch more powerful distributed denial of service attacks. Hackers will focus on hacking IoT devices on a cellular. Now, many IoT devices send messages to the network without any encryption, and this is one of the biggest IoT security challenges that exist out there today. It's high time that all the companies, they have to ensure encryptions of the highest level among their cloud services and devices. Again, some IoT devices I need to mention here, they are designed to be forgettable, and this can be mounted in ceilings, on walls, whether in corporates, could be anywhere at home, and this can be really an issue for IT assets and cybersecurity management because they can be easily forgotten. IoT devices, they are not secure by design because putting a focus on security would significantly increase manufacturing and maintenance expenses. And the first step in protecting IoT devices is to identify them. So the companies, they should scan, the known networks and search periodically for any rogue devices they might have been advertently or maliciously connected to corporate wired or wireless networks. Segmentation also, I can propose here, IoT security remains relatively weak, and the proper segmentation is fundamental to protecting the entirety of the network. Privacy, as you can see here on the screen, we're going to have issues with data ethics, data localizations, how we can define data with, the huge amount of data it's collected, larger volumes of data, identifying the single, source of truth, how the data has been, identified and collected, transparency from, all the parties that are collecting the data, the consent and the access right for the people, if they are given consent for those data to be collected, and the most, I think, important thing, how data is correlated. So we're going to see more and more, like evolution in this. Hopefully, we have seen this more like in Europe with UDPR. Hopefully, here in Canada, we're going to see with the PIPEDA, we're going to see more and more like what we call it, the privacy charter or something similar to it, which gives people more visibility into this. So this is the 5G security challenges and evolving architecture. Just, I wanted to put them here very quickly. We have IoT, machine to machine. We have, vehicle to X, and those threats could be due to peer-to-peer connections and cheap devices with no built-in security. Also, one of the challenges from the architecture perspective, we have a distributed architectures, and we have the threats due to distributed data centers, edge computing, and network slicing. Also, virtualization, and as the core, it's built the 5G on virtualization on the cloud. So the virtualization will increase the complexity in the mitigation, in the mitigating side, channel attacks. Also, we're going to have multiple technologies, and this will have a threat due to multiple technologies and migration of threats between them. I think here also I wanted to put quickly some of the security consideration. Automated network application lifecycle management also will require security tools to not only be on high performing, but also to highly adaptive to ensure the constant, innovation include consistent protection. It also requires organization to transition from the DevOps model to DevSecure or DevSecOps model to ensure the security is integrated directly in the development strategy. Also, the support for the cloud optimized distributed network applications will require security to move seamlessly between and across different network ecosystems without losing track of the workflows or dropping security functionality. Also, the new strategies like network slicing will enable organization to be more efficient, consume resources, moving through massive data environment, and those will require more segmentation and edge-based micro-segmentation to protect the critical resources while isolating them from open and the less secure environment. Here again, this is from a carrier perspective, the threat in the 5G evolving architectures. So here I'm just giving you like how you can imagine, from a carrier perspective, from the device threat, from the 5G packet core. It's a bit, I think, complicated, or maybe for people who works in telecom, maybe can relate to this more. But let me give you on a high level here. The threats is the summary here is we have a problem with security of radio interfaces, which is the radio interface encryption keys sent over insecure channels. Could be a problem with the user plane integrity. It means no cryptographic integrity protection for the user data plane. Also, we're going to have a problem with roaming security, which means the security parameters are not updated with roaming from one network operator to another, leading to security compromises when it comes to roaming. Also, all the time we talk about denial of service attack on the infrastructure, which is a visible nature of network control elements and unencrypted control channels. Here I would just put here, okay, what are the mitigations on a, quickly for those potential security threat. So we're gonna talk. So here I'm putting the, what's the threat vectors and the mitigations. Just quickly to summarize this, 5G requires end-to-end security, but in a virtualized network, virtualized security can be also deployed rapidly to almost any network location and automatically respond when new attacks are discovered. Automation is a critical component of the strategy and is made possible through virtualization. Now, I was reading a report, AT&T's Cybersecurity Insight report. So according to this report, security at the speed of 5G, in this report, it says that enterprises will need to take advantage of virtualizations to make the network nimbler and more responsive with the ability to provide just-in-time services, and virtualization can help provide flexibility to respond to unknown future threats. Also here, some other things I can propose, a zero trust model. And zero trust security model can address some of those concerns by continuously checking the user presence and behavior, whether that user is a human or a machine. Also, security organizations relying on manual security approaches likely will have a hard time keeping up. So security is very dynamic, and automated will be able, this automation will enable them to quickly and effectively address any security threats of 5G networks. So my recommendation for any organization prepare for 5G rollout and applications. Now it's the time to validate your security program. Now is the time to make sure you have the necessary scale, agility, and analytics capabilities to address potential 5G security scenarios. And this will include machine learning, enabled analytics, support for integrated threat intelligence, and automated responses. Here, I just want to mention again what's the, when it comes to the National Security Agency of the United States, they highlight, what are the top cloud vulnerabilities. So those are those vulnerabilities, again, just to, for a reminder, NSA, they're saying about the threat, misconfigurations, poor access controls, and shared tenancy vulnerabilities and supply chain security flaws. And this is the level of sophistications and what, they are recommending. So this is also, we have to keep, this and, in mind, because as I said, 5G is based on virtualization on the cloud, and we have virtualization, we have security issues with the cloud. Also, we have threat and security issues, so we have to take that into consideration. Now, what's the impact of 5G on data management? It's vital to review database requirement for this massive inflow of real-time data. Individuals, as I said, around the globe will generate thousands of terabytes of data, and securing all of this data from criminal exploitation will be difficult. 5G data management is critical to 5G success. The shift from 4G to 5G has resulted in architectural overhaul of the network and requiring network operators to rethink how they're gonna manage the data coming, going, and moving through the network. So we have a need for to support fast data applications with real-time analytics, and fast data mean getting more insight for faster action. So the data are critical in the decision making and value creation, and 5G networks will be the carrier of such data. Thus, adequate protection measures are needed. And as I mentioned here in the slide, as you can see, preparing for 5G adoption will require reviewing current database capabilities, determining whether existing platforms are sufficient for building and accommodating for rapid growth. And the promise of 5G also, it will demand new hybrid cloud data management strategies that allow the enterprises to handle larger volumes of data and meet a higher standard of reliability and performance. So here, I'm finishing the presentation about, privacy, because I think with what we have discussed earlier, from 5G, from the IoT devices collecting a lot of data, and the impact 5G and the impact of data management, I think incorporating and having privacy by design is important. And this is, gonna start with the data governance, trust and transparency and sustainable compliance. So 5G must embody privacy by design approaches where privacy is considered from the beginning in the system, and many necessary features and must be available built in. And good cybersecurity hygiene for such devices start with ensuring default admin credentials are changed or shutting down traffic on non-essential network ports that they are often used for common IoT attacks. So 5G will require better mechanism for accountability, data minimization, transparency, openness, and access control. Hence, during the standardization of 5G, strong privacy regulations and legislation should be considered. My last slide is going to talk about beyond compliance, how to go from good to great. So we talk about the privacy consideration, privacy by design, ethical use of data, enable consumer trust, address a third-party requirement, executive buy-in for this. We need this from the executive, and having a compliance monitoring program. So a hybrid cloud-based approach is required when mobile operators can store and process highly sensitive data locally and less sensitive data in the public cloud. In this way, the operators will have more access and control over data and can decide where to share it. 5G protocols should be designed with attack resistance in mind while phasing out traditional methods that they are not effective anymore. For example, username, password authentication. It's highly likely that new types of security threat and challenges will arise along with the deployment of novel 5G technologies and services. However, if we consider those challenges right from the initial design phases, the deployment will minimize the likelihood of potentially security and privacy lapse. We have to increase attention to fundamentals, and I keep saying that all the time. We need to focus on the core responsibilities. When I say, okay, we have this evolution of 5G and IoT and the massive big data and using AI and the attacker using machine learning AI for attacks, and I keep saying, well, the best thing is we have to keep focus on the core responsibility, meaning you have to know your assets and inventory. You need to understand your organization's vulnerabilities and attack services. You need to classify your sensitive data and the tracking usage pattern of those sensitive data. Using multi-level authentication and layer defenses, ensure device security and improve patch management and more. Now, many companies, they are using numerous siloed security tools, and those security tools, unfortunately, they are not helping. They are adding complexity rather than providing the insight. And those tools do not integrate or communicate efficiently to each other, and they don't provide the visibility, to the security team, and need to establish more seamless, holistic protection, which is required to keep with up-to-date threats. Also, I have to mention here, we have inadvertent insiders leaving organizations open to attack by falling for phishing scams or social engineering, and through the improper configurations of systems, servers, and cloud environment, and by foregoing password-based practices. I think with this security consideration, again, let me say that we need security by design. We need complex authentication, username and password are not enough. We should have a standard for building those IoT devices, and we need for those devices when they are built to be security by design, privacy by design, and we have to be careful also with the legacy systems now when once we are moving with this evolution of 5G and IoT devices. Sorry, I'm not sure if I went over the time, but this is what I have today for my presentation. I hope you enjoyed the presentation and I was able to add something to your knowledge about IoT, about 5G, and the business implications and the use cases. So thank you very much, and if somebody has a questions, please let me know, and I'm here to answer any questions. Thank you.